three things happen when we deal with color. Basically, in our world, when light strikes an object, it can either reflect or bounce off the object. And when that happens, then it reflects all of that light. And when I reflect all of that light, what happens is I'm back to white. Now, it also can absorb, and if it absorbs everything, then I'm back to black, or what we would say black. So that's why in the summer, when you're outside and you're wearing a black shirt, it gets hot. It feels warm to the touch because it's the energy of that light that's being all absorbed. We wear white in the summer to stay cool because everything bounces off and that energy is not absorbed in your shirt. Now we also can transmit. So when light strikes an object, it can also transmit, and that means that when it strikes an object, it actually passes through the object. So one could say, well, that's invisible then. However, there are no truly invisible objects, but there are some gases that we say are invisible. And that's actually getting into the technology with holographs, and the holography world deals with gases and things like that. All right, so now when we look at how we combine colors here, let's just fill this color wheel here. Now this is our additive primaries. Actually, let's make this one blue. And this one green. Notice I color coded my layer so it makes a little bit more sense there. Okay, so now we have our colors. And just to prove this point and how this color works, because we perceive our object's color based on the percentages of red, green, and blue light that are either reflected and then those color combinations of that light produces. So when we're in RGB, you cannot think of it like paint. You have to think of it like light. So just to do some Illustrator skill here, I have 3 circles. You can see they're on their own layer. What I'm going to do is select everything, and we're going to navigate to the Pathfinder panel. I'm going to open Pathfinder, and I'm going to use one of our Pathfinders that divides all of these objects into their own. So I'm going to click Divide. When I do that, remember this becomes a group, but I have many paths in there. So I am going to actually ungroup this under Object Menu and Ungroup, deselect. So now you can see that everything is its own. And I actually can make this be exploded a little bit if that helps in understanding. Okay, so let's put it back together because we want to see the theory of this. So this is all red. I see it's 255. That's all red. This is all blue. In this area in between where they share, let's make it all red and all blue. And you see what happens is now we get magenta. So in the world, what's happening to my object, or what we're doing with light, is basically this area is absorbing that green light. Okay, so that means that green is out of the equation, and it's reflecting or transmitting all of the red and the blue, and we get magenta. So if this seems a bit confusing, don't worry. It's something that a color theory class will define a bit more. And it just is a matter of kind of understanding concepts, I guess. The mixing of color is really unique and odd. Now, what would you think happens in that middle part where they all are together? I said earlier, if you turn all the lights on, what do you get? We get white, right? That's how we get white. So that's the RGB primary color wheel. Now, if we go into CMYK, it's a bit different. So I'm actually going to cheat a little bit, and we are going to duplicate this, and I'm just going to show you my numbers here. So let's actually take this and turn to CMYK. So when my color is set to CMYK, now in reality, if you were going to print, you go to CMYK. It's a subtractive primary. It's cyan, it's magenta, and it's yellow. And then we have black, which stands for K. A couple reasons why they use K. If we used B, it would be confused with blue. but K also stands for key color, and that means it's used for aligning, for registration marks, for some things in the printing world. So with the subtractive primary, we deal with percentages, because now this, in our mind, we think more about ink. So when we see cyan, it's the same thing. They're the inverse, they're reversals. So this is the additive primary with red and green and blue, and you notice that inside then we get the subtractive primary. So we have cyan, magenta, and yellow. So yellow, we know then, is that the blue is being subtracted or taken out, being absorbed, and then it's transmitting or reflecting back that green and red. So for cyan, then it's absorbing the red, it's minusing that red, and we're using the green and the blue. So that kind of, if you can understand the relationship there, it will make it a little bit easier to deal with color. So like I said, CMYK is for printing. RGB is for the digital world. So cyan, magenta, and yellow inks are actually called transparent inks. They're manufactured so that light can pass through them. And so the light that is reflected has not been absorbed by the ink. And this is how we then get, like I said, four-color process printing, or the offset printing process. And so when the color that you see on a printed page is actually reflected off the paper, not the inks. It's a little confusing. All right. So key thing here, I'm going to say it again. The color that you see when you look at a printed page is not reflected off the inks. It's light reflected off the paper. The light that is reflected off the paper is that which has not been absorbed, or we say subtracted, by the inks. Thus subtractive color process. So when you're in art school, you learn that your primaries actually are red and blue and yellow. So that philosophy, that theory, you kind of have to take out of your head when you're dealing with color in the digital world. Okay, so that's color. Now again, there's a whole class that deals with all color theory, and that's something that is important. It's one of those fundamentals that you really should know if you go into that design world.